Photons and other energy particles. The matter in the cosmos tends to form orbital systems, which by occupying a large volume, nucleus with orbitals rotating around it, can maintain the average energy density, dA, that the cosmos as a whole requires. For this, large and important orbital systems, atoms, stars, once they have built their magnetic orbits and in addition to these, need to be filled with energy particles until they achieve the required average density, dA. That is, within orbital systems, in addition to the matter and mass of the nuclei added to their orbital satellites, they almost always need more energy particles to reach that required average density, dA, and therefore the magnetic fields of the system absorb those particles they need. Now, every time orbital systems, atoms, stars, etc., are created, born, destroyed, or there are structural changes, their magnetic fields have to rebalance the total energy of the new or renewed system. Assuming that for this new restructuring of the system, it needs to get rid of part of its energy, well, it does so by emitting energy particles through its powerful magnetic force fields. And this is where the emissions of energy particles in their multiple dimensions and characteristics are born. And this is where our photons are also born, which are actually the smallest particles of energy that are emitted. And its small dimensions are due to its high emission speed c. As the particles get larger, their emission speed will decrease. But why does this happen? Well, because apparently, by observation, the relationship between the dimensions of the magnetic field that emits them and the dimensions of these particles is what gives the speed of said particles. That is, the emission speed of a particle by a magnetic field will be directly proportional, ratio, to the dimensions of the particle with respect to the field that emits it. Therefore, we see that all energy particles, including photons, are filling components of orbital systems, which, and by the action of magnetic fields, are captured or emitted according to the energy needs of that orbital system. For example, in a chemical reaction between two atoms, one of them may need to emit a large amount of energy, and it will do so in the form of heat, larger particles, or even in the form of photons, which will acquire a lot of speed due to their small size. Of course, each photon is unique and its range is very extensive, its size currently being measured as a wave frequency, although this consideration is not totally accurate. Example. Allow me to give an example, although it may seem very crude and strange. And it is the possibility that our lonely solar system found a suitable and necessary star to take as a partner. In this case, the two stars would first approach each other by gravitational complementation, and immediately align themselves polarly ns, so that they could get close enough without there being rejection or collision of magnetic or gravitational fields. Once aligned and close, the planets necessary to complete their gravitational and magnetic orbits would be exchanged or shared, and they would proceed to expel the excess energy from the new composite system, or molecular system. Well, among these leftover particles, expelled from the new composite system, many of our photons would already go, among many other types and dimensions of particles. That is, in both atoms and stars the same phenomena of expulsion and emission of energy particles of all types and dimensions occur, heat, multiple types of rays, photons, etc. Friends, thanks for your interest and kindness.